Hi, thank you for watching this video. In this video, we are gonna be talking about the construction and evaluation of a calculator using logic gates and basic inputs. The goal of this project was to construct a calculator using logic gates and basic inputs to be able to demonstrate the calculator's functionality. In order to qualify as a full calculator, the architecture should be able to handle the four basic operations of arithmetic: addition, multiplication, subtraction, and division. The construction of this calculator will be made in Logisim Utility. Logisim is an educational tool for designing and simulating digital logic circuits and is an open source application. This is an 8-bit adder. It can add up any two values provided the result is fewer than 8 binary digits. In this case, values A and B are added and output to sum. Each gate is represented in reality by a transistor circuit. The D-shaped AND gate will output a current if both inputs are providing a current. The triangular OR gate will output a current if at least one input has a current. This highlighted section is the D flip-flop. It is one of the basic memory constructs that allows the computer to remember data. It can remember one bit of information, which can later be retrieved. By linking these basic units together, one can form complex change that can remember many trillions of bits. This is an 8-bit flip-flop. It can keep track of previous circuit states up to 8 bits, and then retrieve that information based on a signal. Often this signal becomes the form of a clock in an actual computer system. This section is a D flip-flop. It is one of the basic memory constructs that allows the computer to remember data. It can remember one bit of information, which can later be retrieved. By linking these basic units together, one can form complex change that can remember many trillions of bits. This is how a 4-operation 32-bit calculator can be represented in Logisim. Each module represents a system of logic gates in addition to there being logic gates in a diagram itself. The calculator takes and stores input, records an operation, takes a second input, and performs the desired operation. This is the renderer, which manages output. The display itself is actually a set of logic gates, so in order to get the display to show numbers, a complicated system of logic must be implemented. Fortunately, this circuit is available in one of the Logisim libraries. This is the basic display without any output. It takes a 32-bit binary number and displays its decimal equivalent. This is where the arithmetic logic is implemented. Each module represents a complicated system of logic gates that can add, subtract, multiply, or divide a number up to 32 bits of space. It takes input from what is known as a register and outputs to another set of registers. These are the registers. They are basically temporary memory spaces for holding the numbers used in the calculation. They are a type of flip-flop which can hold 32 bits values. This is the cache, which holds the result. These are again more flip-flops modules. They hold the result so that if the user desires, calculations on the result can be performed.